Our last section in Chapter 7 is Section 7.5, Proportions in Triangles. The side splitter theorem says if a line is parallel to one side of a triangle and intersects the other two sides, then it divides those sides proportionately. So then that means that we can set up a proportion to solve for our missing sides. So example number 1, we want to find y. So we note that MN is parallel to BA. So therefore we can use the side splitter theorem. We can say that 12 over 10 is to y over 6. So again, when we set up our proportions going in the same order, I could have put 12 over y, 10 over 6, 10 over 12, 6 over y, but just making sure that we go in the same order for both ratio. Then take the cross product. 12 times 6, 72. 10 times y is 10y. Divide by 10. Y equals 7.2. Same idea number 2. If we have right angles in both of our triangles, then we know our lines are parallel. We have congruent corresponding angles. So I can set a proportion to solve. I can say that x plus 1.5 is to 5 as x is to 2.5. Then taking the cross product, so 2.5 times x plus 1.5 equals 5x. Distributing on the left, getting x on one side, so let me just draw a line there. When I subtract, I have 3.75 equals 2.5x, and then dividing and getting x equals 1.5. Same idea in my next examples. I can say 3 over x is to 4 over 6. So I can put top over bottom equals top over bottom. Then taking the cross product, 18 equals 4x. Divide by 4. 4.5 equals x. In number 4, I can say x plus 4 over 2x minus 2 equals 5 over 8. Cross product here, so 8 times x plus 4 equals 5 times 2x minus 2. Distributing on both sides. Then I can subtract 8x. Add 10. Divide by 2. X is 21. Now my next examples will be set up a little differently like the previous ones. If you notice in number 5, we are given the sides of our small and large triangles and we're given the bases. So I can put side of the small over base of the small equals, now the side of the large one, I have to add these two together to get 4 over base of your large triangle, which is 12. Then take the cross product. So 36 equals 4x. Divide by 4, get x equals 9. Same idea in 6. Side of our small triangle over base of our small triangle. Then I have to add these two together to get the side of my large triangle. When I do that, I get 2x plus 2. So we'll put 2x plus 2 over 25. Side of the large triangle over base of our large triangle. Then taking the cross product, 25x equals 10 times 2x plus 2. So 25x equals 20x plus 20. Subtract 20x. So 5x equals 20, and then finally divide. X equals 4. Let's look at 2 more examples in this section. So similar to our last 2 examples, in number 7 I can take the side of my small triangle over the base of my small triangle, then adding these 2 together to get 16, I will take side of the large triangle over base of my large triangle. Then take the cross product to solve. So 12 times 4x minus 2 equals 16 times 2x plus 5. Distribute on both sides. So we have 48x minus 24 equals 32x plus 80. If I subtract 32x, I have 16x minus 24 equals 80. If I add 24 to 80, I get 104. And then finally divide both sides by 16, x equals 6.5. All right, one last example. So side of my small triangle over base equals, now my side here will be 5x plus 70. I can't combine those. So side of my large triangle over base. All right, now this one's going to be a little trickier. We take 5x times 8x plus 4 equals 20 times 5x plus 70. When I distribute on the left, I will get 40x squared plus 20x equals 100x plus 1400. Now, I notice I have an exponent to the second power here, so I'm going to bring all my terms on the left and put my quadratic equation in standard form. So when I subtract 100x and 1400, I'll get 40x squared minus 80x minus 1400 equals 0. Now to solve an equation like this, we have to factor. And the first thing we look for is a GCF, or a greatest common factor. So this is going back to Alg 1 here. Well, my GCF is 40. So if I factor 40 out, I have x squared minus 2x minus 35 equals 0. So keeping that 40 out front, making 2 sets of parentheses, factoring x squared, and then finding factors of negative 35 that subtract to give me negative 2. So x can be negative 7, positive 5. Those are my factors. Then, to solve for what x is, set each of these factors equal to 0. So here we get 2 answers. X can be 7, x can be negative 5. Now, if I go back to my original triangle, I see that the shorter side was 5 times x. Well, if x is a negative, then that means my side length's negative, which I can't have that. So I have to reject negative 5. So my only answer is x equals 7. And this concludes our section, Proportions in Triangles, and this also concludes Chapter 7, Similarity in Triangles.